So today we'll talk about solutions. Remember what we said in terms of the classification of the matter. Matter is classified into pure substances and mixture. And then the further classification for pure substances are elements, which are the elements on the periodic table, and compounds, which is a combination of compounds, which is a combination of more than one atom that is in the periodic table. So even on the case when we have O2, it's a compound because two atoms of oxygen are bonded together to form the oxygen molecule. Then the second branch of the matter is that is known as a mixture. And on the mixture, we have two parts as well. That is known as the mechanical mixture, where you are able to visibly see the parts that are forming the mixture. And the second one is solution. Today, this is our focus. This is where we will focus on this part or on this subgroup of the matter classification. And we will see it from different perspectives. So now, a solution is made when two or more pure substances are combined to form a mixture. Okay. Usually, one of those substances is water. Okay. Now, you have to keep in mind that, and this is the definition taken straight from your textbook on page 43, which is chapter 3 of Unit A. So different solutions that are examples of the solutions are those that you see here, like Coca-Cola, Windex, even a vinegar because it is diluted, or this, which I'm assuming that it's either fruit punch or some tomato juice. And in every solution, what do you have? There are two parts. Is the solute, which is the substance that dissolves, and the solvent. When they are mixed together, then what they are forming is a solution. The best solvent that we know in the world of science and chemistry is water. So an example of a solution will be when you take some sugar or salt, that is sugar or salt, that is the solute, and then you pour it into a container of water. And then as a result of this, what you will have is the salty water or sugary water. And it's a solution. Now, when we are talking about the concentration, it's telling us, it's giving us an idea as to what is the amount of solute in the solution. So usually the units for concentration are grams per liter. So they are telling us how many grams are in 1 liter of solution, okay? Or, yeah, solvent. So when we have, let's suppose that in the label we have a concentration of 7.0 grams per liter, this means that in this type of a solution, you have 6 grams of whatever, on this case is glyphosate in 1 liter of water. Glyphosate is the solution while water is the solvent. So you will see that in 1 liter of water, you are dissolving, you are putting in 7.0 grams of glyphosate or whatever is the solute. It can be salt, it can be anything. Okay, so let's see now. What do we have here? When the concentration is increased, so when we have 2 solutions, solution 1 with a concentration of, usually concentration is with those little brackets here, with a concentration of 7.5 grams per liter. And then on side by side, you have a solution 2 with a concentration of 15.3 grams per liter. That means that solution 1 in comparison to solution 2 has less. This, for the simplicity, let's consider that the solute is water and the solvent is the solute is salt. So solute is salt and the solvent is water. So for solution 1, what we can say is that in a solution 1, we have 7.5 grams of salt diluted, put in to 1 liter of water. On 1 liter of water versus what we have on solution 2 is 15.3 grams of salt, whatever is the solute. In this case, we assume that that is salt, but diluted into 1 liter of water. So as you see here, solution 2 is more, we use the expression, more concentrated. And usually, if the solute has a color, then what you will see, the more concentrated the solution is, the darker the color it is. So when we see this picture here, then we see, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then we can say, based on the color that we see here, that the solution on the 11th beaker is the most concentrated one in comparison to solution on the other beakers, because the solute has a color which the more you are adding into solvent, then the darker the color will become. So now what do you see even in the supermarket is that you see some boxes, like carton boxes, that are with frozen juice. And they are concentrated products, which means that what do you have to do is you just have to add water into it, and then you will make a given juice. The example that you have here is that those Minute Maids orange juices that are here on this side are concentrated. And then while this one here that is in the box, it is a diluted one. It's ready to be used. What you will do on something like Minute Maid is you will take 1 or 2 spoons and then you will put them into a glass of water and then dilute them. Versus what you will do on the Tropicana boxes is that you will just take the box as it is and pour it straight into your glass and then drink it. Solubility, on the other hand, describes it's a way that we tell how easily a solute will be dissolved in water, in a solvent. Okay, so there are some that are very easy to dissolve and some that are not easy to dissolve. The substances that are easily dissolved, they are called, they are classified as soluble. And the substances that will not or have a very hard time to be dissolved into solvent are called insoluble. So an example of a soluble solution or a soluble material substance is sugar, water, orange juice, or so. And sugar, salt, not water. And an example of not insoluble, something that is not dissolved into solvent, is, let's say, oil. Oil, it cannot be mixed with water. Solubility depends on how much solute is added to a mixture. There are too many factors that affect the solubility of a certain substance, but the most important one is the temperature and the stirring effect. So, example, when we have a glass of water and we are adding some sugar or salt on it, I'm bringing examples so that you can relate to. And then you can leave it there, and then eventually the sugar and the salt will be dissolved in water, and in 1 day or 2 days you will have salty water or sugary water. However, what we usually do in order to keep the molecules of sugar and salt moving is the stirring it up so that the mixing is happening. On the other hand, you know very well that if you have a glass of water that is cold, frozen almost to 0 temperature, and a boiling one, then the salt or the sugar will be way faster dissolved into the boiling water in comparison to the water that is close to frozen. So temperature and the stirring one plays a huge role into the how fast it is dissolved, the solute. However, as I said, and as I mentioned, oil and gasoline do not mix with water. This is one of the reasons why oil and gasoline are harmful to environment. So when we are working with oil and gasoline, we have to keep in mind that they do not mix together. Okay, so now let's move to separating mixtures, and separating mixtures is actually on your 3.3 on page 50 in your textbook. Now, every time that you see that when you see something, it looks like pure substances, we know that they are composed by tiny particles. And there is more than one type of particle. So in order to clean, let's say, the water, which is the most useful thing that the separating mixture is used, what we do is we take away those particles, leaving the particles that are more leaving that are less and less and less and less until you are ending up to have something that is pure. And the most useful case that we use into our life is water purification. We know that water is infected, quote unquote, by micro particles that some of them are not as good for our body. Therefore, we have to clean the water. And then the water that is coming from the stream, this being a lake or a river, it is coagulated, meaning that it is allowing the big particles, heavy particles, to settle down, and then it is sedimented, which means it's the second process here, which is making those heavy particles to sink at the bottom of the mixture, and then it is going through filtration, where it is filtering and removing the solid particles from water. It is disinfecting, and this is where they are putting chlorine to kill the remaining bacteria. However, keep in mind that with bad bacteria, chlorine is killing good bacteria as well. And then the clean water is stored. The pure water is stored for later use. In your textbook, I would suggest you try to do the investigation 3-C, which is making dirty water clear. So this is good, especially for your if you are big into camping. So if you are running in a situation that you do not have clean water, then what you can do is you can use the investigation 3C on page 51 to clean the water and have clear water to drink. Okay, this is very good because you can clear water with actually anything. Even paper, ashes are very good for cleaning water. How easy it is to have the fire going into the camping and then use that ashes to clean the water. Okay. But besides whatever you have on investigation 3.3-C, the water can be purified through the process that is known as the water distillation. The water distillation is and what is happening is that the water is boiled and then the steam is captured, is condensed to form pure water, and the steam is accumulated, and then what we have here is the distilled water. You see distilled water even on at the supermarket. If you go to superstore or so, you will see some distilled water bottles that you can use for other things into your life. However, you have to keep in mind that even though distilled water is clean of bacteria and particles, because it is just steam, water in the gas form, H2O gas form, that is condensed and then it is accumulated into a pure water form. There are a lot of things that are needed for our health, which distilled water doesn't have, like minerals and salts, different minerals and salt that our body needs, even though that it is so not harmful, but we need minerals and salt in our water. Okay, so this is in regards to chapter 3. I will finish it now because there is not too many things to say in this chapter, and you can see it and review it